So this video is going to be about precision and recall. Precision and recall are two metrics that scientists use to judge the validity of a model. Now you might be wondering, why not just use regular accuracy? Well, there's several problems with regular accuracy that make it inappropriate to use in certain occasions. Accuracy is not a good metric to use when there's a severe class imbalance between the classes that you are trying to predict. So, an example where accuracy is okay is when you have a model and you give it some images and you're saying, okay, is this a cat or a dog? You might expect in the real world there are about a 50-50%, there's a 50-50% balance between cats and dogs. So that's okay, accuracy is a good metric. However, in this problem, the pothole detection problem, the distribution between roads with potholes and roads without potholes is not a 50-50 balance. It's more like 3 and 97%. 3% of roads have potholes and 97% don't have potholes. Obviously that varies based on the location of where you're using the model. So think about it, a naive model that predicts no pothole for every single occasion, no matter what, would achieve an accuracy of 97%. Now that might seem good at face value, but obviously now that you think about it, it's obviously not good. We're not doing anything. We're not detecting anything. We're not bringing any new value. Our model is not bringing any new value. So data scientists, statisticians made these metrics to make it easier to judge the validity of a model. So if you look at this chart here, this is a chart representing the different occurrences that could occur when you're classifying a certain pothole. So here, this is the predicted. So this is what the model predicts. And this is what's actually in the real world. So if this, a true positive is when the model predicts that there is a pothole and there actually is a pothole. The model did a good job. A false positive would be when the model predicts that there is a pothole, but there actually isn't. It's not there's no pothole. It's a false positive. Here, a false negative is generated when the model predicts that there isn't a pothole, but there actually is. And a true negative is generated when the model predicts that there isn't a pothole and there actually isn't a pothole. So as you can see, these are various occurrences. These are various things that can happen when the model is trying to classify a class. And so these are the two metrics that statisticians use. Precision. Precision is true positives over true positives plus false positives. So what does that mean? Out of all of the ones that the model predicted as positive, how many of them are actually positive? That's what they're asking. So that's one metric that is used. Another metric that is used is it's true positive over true positive plus false negative. So out of all the things that are actually positive, how many did the model classify? So out of all the potholes, how many did the model classify? And so those two metrics are very useful when you're judging the validity of models where there's a severe class imbalance.